So, in order to calibrate your 3D scanner, your Makerbot 3D scanner, the first thing you have to do is you have to go to this website, Thingiverse, and download the calibration tool. There are a lot of other projects that you can make here, and I recommend you exploring and looking at some of these, but that's not what we're talking about today. You basically enter right here, you type in Makerbot Calibration Tool, and you do a search, and you wind up with this. And this is what you download. It's called cali.stl. You click here to download it, and it comes to your download files. Once you've downloaded this, you print it using a white filament and on your 3D printer, and this is what you use as the base for your calibration tool. This is the only thing I can find. I have called Makerbot, and they refer you to this tool. This is fundamentally it. Now, whether it is exactly the right size or not, I don't have really any idea. But this is the one that I used, and this is the one that's in my video. And so I got it to work, and it seems to work well enough. So this is the one I use. Now, once you've downloaded this, and you got to remember, this thing is going to take, if you do it on a real fine resolution, not low, medium, but high quality 3D printout, it could take you 20, 25, maybe even 30 hours to print. So be prepared that this can take a long time, because you want a good quality, good printout, no blemishes. You want it to be the best quality you can make when you print this out, because you have to use this to calibrate the 3D scanner. So speaking of the 3D scanner, let me tell you where the software is for the 3D scanner. And here it is. You go to your computer, C drive, program files, Makerbot, Makerware subfolder, and you go down to Digitizer EXE. I never found this anywhere on the web. It wasn't explained anywhere. There are only certain versions of the Makerbot desktop software that you use as a slicer for your 3D printer. When you install that, it has this digitizer software already bundled with it. In fact, when you install it, there's a little box you click to select installing the digitizer software, and that's the only notice I've ever seen of this digitizer software. And there are multiple, I've tried multiple versions of the digitizer software, linked with different versions of the Makerbot slicer for their Makerbot Replicator 2 3D printers. And no matter what version I use, I don't get a better quality scan on the 3D scanner. So you might as well download the most current version, come to this folder, and launch this digitizer software. And when you do that, you will get this. Once the 3D scanner, digitizing scanner is plugged in and all the software is installed, and you turn it on and you launch the software, and you may have to launch it a couple times. You may have to turn the power on and off. You may have to run the services and do a restart background services a couple times. But eventually, if you leave it, it'll come up and you'll get this red screen and these four little options to do a scan. So with the software, there's not a whole lot of choices to make as far as changing the scanning of your object. Now, I'm not going to scan the digitizing, the calibration tool, but when you do scan, you have basically this option only right here. You can scan light, medium, or dark. And when you do the calibration, I suggest you use the light. That seems to work the best. I also suggest that you put in the background some black cloth that is not shiny. It has to be kind of muted, or a piece of foam core. You don't want any sort of other red objects showing up in the background, like something like this. You don't want anything encroaching on the image. You want this to be as clean as possible. Now you see a little bit down here. That's the tape, and I'm going to leave that because that's not too bad. But you can even see there's a little bit of a reflection here that causes a problem because of the light. But technically, you want this as dark back here as possible when you do calibration and when you scan objects. In addition, you want the light to be overhead. So when you calibrate, you want an overhead light, not a side light. You see how that kind of distorts everything? You don't want a side light of any sort. You want a direct overhead, preferably in the back of the printer, of the scanner. You want the scanner facing the wall against, right up against a black background. From there, you do your calibration. And your calibration, the first time you launch this software, it will ask you to calibrate. You can't run the software unless you get a clean calibration. So obviously the first thing you have to do is download this frame, make your calibration tool, and then after you've finished making your calibration tool, then launch this software for the first time and try to calibrate using your tool, and it will be automatic. But once it's done automatically, you're still going to need to do some hand calibrating in order to dial in your calibration card. And I highly recommend you go ahead and make your calibration card, calibrate your scanner, and try scanning something. Maybe it'll come out perfect. You know, my calibration card is a little off. I'm not really sure why. Maybe some of the measurements are off. I don't know. So what I wound up doing was tweaking the lasers during scanning of an object to get it to be a perfect scan. And what happens is, and I'll describe this more because I'm actually going to scan something and show you how I tweaked the scanning, because there's only a couple ways to really adjust the scanner. One is you have a calibration card, that's it. The second thing are these options right here. The third thing is you can manually use your number 15 Torx wrench and adjust the Torx screws in the back of the scanner on the left and on the right, and move the left and right laser. And I hope I'm being clear on this because I don't really have a diagram of it. The laser crisscrosses. And that's what this option right here does. Align lasers. And you can see it here. Basically, it tells you how to align the laser. However, for my card, that did not work very well at all. Even though the tool calibrated and said it was a good calibration and everything was fine and honky-dory, when I actually went to scan an object, it came out like hell. It was really bad. So what I wound up doing was I used this option over and over, this align laser option. And what I did was I aligned them so they crisscross. You can see that they're using the calibration card here first to get the vertical. And that's what you kind of do. You tweak the outside Torx screws so that the top and the bottom of the lasers align perfectly vertical. And then you tweak the inside Torx screws so that they crisscross right there in the center of the table. Then you run your calibration. Then you're done with this the first time. Then you run the calibration, all these calibrations again. And after you've done that, I encourage you to scan an object. Like here, I'll show you. Let's grab a particular object here. And I'll show you why I picked this object. This is a little octopus, and he has a bunch of arms. And they all stick out. And that's exactly what I want. And I'm going to scan him on the dark side, just so that we get a good picture while I'm scanning. But before I start to scan, I want to finish up with describing how to tweak the center of this laser alignment, because that's really the only thing you can do. You can make it lighter or darker in the software, and then you tweak the laser so that the point at which they cross moves somewhere around the turntable. They said, like I said, and I'm trying to make this clear because I don't really have a picture, they want you to line the laser right there. Well, sometimes you might get a better alignment here, or in the middle of this platter here, or further back, or over to the right here, or over to the left. I encourage you to move that crossing point all around the platter, and then do a scan, and move it, and scan it, and move it, and scan it, and move it, and scan it, until you get the best scan you can from your calibration. And you can adjust the scan, the lasers using the number 15 torque wrench. You can move that around while you're scanning in real time. I encourage you to do that. Don't be afraid to do that. It won't hurt it. Now, your scan is not going to come out well, and we're not really concerned about the end result of the scan. What we're interested in is the top view of this object, and I'll tell you that I'll talk about that in just a second. I'm going to start the scan now, and it takes about 9 minutes to start to finish, and it also takes a minute or two to generate the mesh and then show you the product. There is some cropping, but the cropping is basically useless. It just crops from the top and from the bottom, and that's it. Something I did notice was when you do your calibration, up here, when you do your calibration, you want the overhead light on in the room. But when you do your scan, you can scan it with the overhead light on, or you can do it in pitch dark. It makes no difference because it's only reading the red laser. If the red laser is picked up because there's a filter on the camera. If I slide the filter over to the right, everything changes to just a normal camera. When I slide the filter back, it only sees red. And so anything red will be picked up. So actually, scanning in pitch dark is really not that bad of an idea. You can see the background here is all pitch dark. That's exactly what you want. You only want an image right here to be reflected. So that being said, I'm going to talk more about scanning and why I'm using this octopus with all these arms. So let's go ahead and start the scan. And it takes a few seconds. Oh, I got a yellow screen, which is not good. Typically, you don't want the yellow screen. So let's see if I can stop it here and restart it. So I've restarted the scan, and you can see the background here is all clear. There's a little initial lock of the motor, and then the left laser will come on and start to scan your object. And that's what you see happening down here. Now, what you can do is, and this is what I did, was I did the view from the top, and then I moved in quite a bit, like that. And what we're seeing here is the first leg being scanned from the left laser. So we're really going to get two images. We're going to get a left image from the laser on the left and a right image from the laser on the right. And then what it does is these two images are supposed to overlap perfectly. Well, when I first started scanning, they were way off. And that was because where the two lasers crisscrossed in the middle of the table was not in alignment either with my calibration card or my scanner was slightly off. I have no idea. I never solved that. What I was able to solve was I let the first laser on the left scan the complete object. And we'll see 8 arms. I have 2 arms here coming up. There's one arm here, and here's the second arm. There will be a total of 8 arms. And when the second laser on the right kicks on and starts to scan, I want to make sure that that scan overlays each arm correctly and in the right position. Meaning, right now the left laser is actually recording the left side of the octopus here. And this is the left side of the octopus. The right side, that's all spotty, has not been scanned yet. So what it really does is it does a 2-path system. It scans the left side completely, and then it comes back and scans the right side. And it's critical that when the right side is scanned, it has to line up with the object in the right position on the right side. And that's why I'm looking at it in top view here. I want to watch all the parts come together. And if they're off, then you want to move using your number 15 torque screw driver. You want to move the laser, the right laser, left or right in order to get it to match up with the original scan. And what I found, and you'll see here in a second, I'll zoom in so you can actually see the second portion. Mine's all dialed in. I'm not fiddling with it. But you're going to have to fiddle with yours because it's going to be way out of whack and the object's going to come out really bad. Unusable, basically, if it's as bad as mine. But once I got it dialed in, what I did was I positioned the crosshair where the lasers crisscrossed to where I got the best overlaying of the two objects, of the two halves of the object, the left and then the right that will be printed. And I moved that crisscross forward near the camera and further away from the camera. And when I found the position that was the best in between, because it can't be too close and it can't be too far away, it just doesn't work at all. You get nothing. You get a failed scan. But somewhere in between, you're going to get a really close layering of the left and right side. They're going to match up just perfect, except you're going to find that the very end, the second right side scan is going to be back here, and it's going to be too low, or it's going to start out here and be too high. And that's when you move the laser left and right from your sweet spot on your table in order to get that second scan to match up right with the very tip of your scan. And we'll see that here in just a second. Mine is a little bit off. I mean, I think it's maybe a fraction of a millimeter. It is definitely smaller than the resolution of the scanner. I think the scanner has a 2 millimeter resolution. So you're going to get plus or minus 2 millimeters no matter what you do. Now we are getting close to having the last leg here. 1, 2, 3, 4, 5, 6, 7. This is the 8th leg. And I will try to move in very carefully and show you how the second side of the object is scanned, the right side, the right laser. So here it's going to be done. And there it's done. Now it's getting ready to start the second laser. And now the second laser is on. And you can see it starting to come in here. Let's move in a little bit. And you see it's actually filling in the segment of the octopus. And it's coming down here. And it's filling it in. And now it's coming around here. And you'll start to see it scan some objects down here. You'll start to see some things starting to come down here. Because now it's coming down. There it is. Whoops. You see it's coming in right there. And I'm a little bit off. Now that's not a big deal. That's actually very acceptable. And so now it's scanning the right side of the object. And these are all laying over very well. If you notice, the octopus is actually segmented. And these are the different segments. And so it's coming around. And we have 3 minutes remaining. But like I said, you want to get your second scan, here it is right here, the leading edge of the second scan, to match just perfectly. See, I'm a little bit off, not by much. It's not worth tweaking. I don't think I can even move the laser that little. Let's see if I can get here. You're going to start to see it come in right around here. Well, there it just went. Okay, so that one actually worked out pretty well. We'll come into this one. Move it back. This one here. That's why I do about 8 of these, because some of them work out better than others. You can see a little difference here. And here's the leading edge of the scan. We have 2 minutes left. And like I said, you move it left or right to get it to align so that you get the whole object this way and you get it oriented this way. You see right there. I'm a little bit off. There it is there. There it is there. That is such a small amount, it's not even worth fiddling with. So that's why I used the octopus, because it gave me multiple times to try to lock this in. And we're almost done. This has got to come around a little bit more. We have less than 30 seconds. And it's still coming in, still rendering it. But this is darn good compared to the way it used to be when I first had it. It was so miserable before. You fundamentally couldn't do anything. And here we are coming around to the last portion. Just a few more seconds. And then it's going to do some rendering, and then it's going to render it. And it's going to be pretty decent quality. Let's let it finish here. You can see right there, it's finishing up right there. That's very close. And this are very close. So by moving it left or right, it moves it in and out. And by moving it forward and back, moves the second scan left and right. And that's basically what you do, is you fiddle with those 2 screws until you get a perfect second layering, overlaying of the second laser, the right laser, on the object, so the object comes out perfect. And then once you do that, that's the best scans you're going to get. And I found that dark objects don't scan very well. Shiny, reflective ones don't scan. You can put powder, baking powder, or baby powder on it to make it less reflective. Light-colored, muted things work well. Horizontal sides or horizontal portions, like a coffee mug that has a handle. The horizontal part of the handle does not really come out very well at all, because the laser basically is parallel to that surface and doesn't pick it up. So you have to do a multi-scan where you turn the cup 90 degrees. I still haven't really gotten that to work too well. And they say don't use the multi-scan feature, and I'll show you that in a second, more than 3 times. 4, 5, 6 times just causes a problem, makes it worse. So it's like a bell curve. 1 is maybe not the best. 3 is about the sweet spot. Maybe 2 is the sweet spot. Maybe 1. And then any more than that, you just get it worse. So you can see how this is all coming in. It's all scanning this really well. I think that's the last of it. I think that should just about be it. I think we've already done this one. Oh, here it is right now. You can see I got the tip there really well. Here's the second side coming in right here. And it looks a mess, but these are just points. And then the software goes in and takes those points and works them through a mesh to make it a three-dimensional object. And normally, I mean, this was $1,400 brand new. I picked this up for under $200. Normally, in order to get a really good three-dimensional scan, you need a scanner that's maybe a $10,000 scanner. This is a very good entry-level scanner. So it's generating the mesh, and it will come up with an object here in just a second. And there it is. And so it's not It's not the prettiest. It's got some segmentation here. You can see all the different segments. You can definitely see the two eyes and the little mouth. The head looks mostly round, little divot there, not too bad. But then again, this is just an octopus. I'm not really trying to do anything too fancy here. But let's get back to the view, the home view. You can do a multi-scan if you want. It tells you how to do it. You click on this and it'll give you some information. You can crop the scan area. It basically makes a bar up here and a bar down here. I'm not going to do it because it always messes up because my computer freezes up. So, but cropping up and down makes no difference. If you have to do that, then you need to clean up your background when you do your scan, and you need to align your lasers. So I hit the finish scan. And now I can scan again. I can save a copy, an STL. I can print it if I have a Makerbot printer plugged into my computer, or you can share it. I don't share any of it. So that's fundamentally how to adjust the software portion of your scanner and the lasers, how to adjust the lasers. Now, I didn't show you how to physically align the lasers because it takes a long time, and I don't want to mess up my calibration. But if you fiddle with it for a little while, you'll get the idea. I think I've been pretty clear on how you use this option here to move where the lasers crisscross. First, you start here and you try your calibration card and see if it works. If your object comes out miserable, then start moving it from the front to the back, and somewhere in between there you'll find a sweet spot. Let's say it's like right here at the first ring or the second ring. Then you need to move the crisscross of the laser left and right, again using the torques, and you can do it while it's scanning. So scan something that has a lot of fingers on it so that you can try it multiple times, because it'll change instantly. As soon as you move that laser, the points will readjust, and you can move it around and position it a little bit. And then once you get it dialed in, then come back and scan the object completely, and you will find that you get a much better scan, and it'll be fairly good, even with some low-level detail. So that's what I have found. It's not the best process, but if you don't have a scanner tool or a calibration tool, you really don't have an option, and you can't buy them. So until they become readily available, this is the only way to do it. After buying my Makerbot Replicator 2 3D printer, I thought it'd be kind of cool to get the Makerbot Digitizer Desktop 3D Scanner. They're both made by the same company, and I like the quality of the Replicator 2, so I thought might as well get the Makerbot Digitizer also, a 3D scanner. And that's what you see here. This is the 3D scanner and the calibration tool. Now, there's a lot of these on the market, on eBay and Craigslist and other selling sites. They're all over the map. Some are as expensive as maybe $1,000. Some are as cheap as $150. The real key for these digitizers is this calibration tool. And without the calibration tool, it is very difficult to calibrate the 3D scanner. Digitizer scanner, and without good calibration, you wind up just with garbage. The image that's scanned does not come out. It's not even usable. So this video describes in two parts. First, the first part is going to describe how to make your own calibration card, and that's what I did. I actually made this one myself. I have called Makerbot and got some specifications on the card, but they do not sell them. I have not seen any for sale online, and so it was really difficult to replicate closely this calibration card. I think I did a fair enough job. Mine is not absolutely precise, but it is good enough to calibrate the scanner, but not precisely. In order to get the calibration of the scanner more precise, the second half of this video is going to describe how to align these lasers precisely to match your calibration card in order to get a good rendering of the item that you are 3D scanning. And that's what this video is going to describe. So let's talk a little bit about the calibration tool. It is overlooked on the web. No one really describes the tool very well. I can't find one for sale. I've called Makerbot to get specifications on it, and it was a little bit not difficult, but hard to relate the information I needed to make one. They do have one at Makerbot if you call them. Sometimes they may or may not be helpful. I'm giving you too much information. Theirs is broken, and they have none for sale, and they don't know, the manufacturer I don't think is around. So I don't think Makerbot actually made these scanners or these calibration tools either. It was outsourced, and I don't believe that they have a whole lot of database, customer support, technical support on the card itself, or on the tool itself, calibration tool itself. So you're kind of left up to your own ways of figuring it out. I believe my card here is about 95 to about 98 or 99% correct. Now, I've never seen one of these cards in real life, so I had to make it only from what I saw on the web and what was readily available. So when I do calibrate the scanner, it does pass calibration. However, when I go to scan something, an object, it doesn't come out absolutely perfect. Not that it ever will, but especially with this level of scanner, 3D scanner, I would say the 3D scanner, the Makerbot 3D scanner, 1 out of 10, from 0 to 10 or 1 out of 10, probably when it's all dialed in the way I've shown you here, the best I can get about a 5.5 to maybe a 6 out of 10 as far as scannability. Just using the card, I get about a 3. There's 2 ways you need to dial in the scanner for calibration if you don't have the original calibration tool. That doesn't mean you still can't use it, but it's going to be a little bit more difficult and a little bit more time consuming. But if you watch this video, I will try to describe exactly what I did and show you the best results I got. So let's, again, start out just with the calibration tool. There's a lot of parts to it. I looked on many videos on YouTube and didn't really find anyone who went through the calibration card and described how it works and how it's laid out. And I want to do that now. So given this card, this tool, I keep calling it a card, the frame that you see here, this plastic frame, you can download from Thingiverse. And they do at Makerbot suggest downloading this. You will need to print out using white filament the frame. Another part of this calibration tool is not only the frame, but there's a card here in front that you can remove, and you can see I have 2 parts here. And this is just foam core. The card here is just foam core. And I cut it to size, and it just pressure fits right in between the legs of the calibration tool. Another thing to note are let me move it back here, the squares of the calibration tool are different. So the calibration tool card, the front face, that is really part A and part B, these squares are 1.2 millimeters in size. And the squares on part C are 1 millimeter in size. And there's also a distinctive pattern to the card. This card, there are 4 squares here and 5 across the top and to the left and towards the bottom. The 4 must be oriented on the right of the calibration tool when you insert it. That's because when you go to orient the card around the turntable, which I'll show you later, it'll be in the right position. In addition, the smaller size interior grid pattern, there's 3 squares here and 4 here and 5 along the bottom and along the top, and same with up here. It's orchestrated the same way. 3 along here, 4 along the right, 5 along the top and the bottom. So you basically print it out, and I printed it out this size, and then I cut off, you know, this much of it to paste it in here. And again, this is 1.2, this is 1 millimeter. So those are different sizes, and I will have those files available to download, and you can print it on your printer and then cut it out. And I just used double-sided tape, sticky tape, to hold this to the card here, and double-sided tape to hold this nice and flat and clean to the calibration card. In addition to the calibration frame, I have added these parts that you can add to the feet. You can see it right here, here, and here. When you download the calibration card, it's just going to have this thin little leg connected to the frame. And I'm prone to breaking these bad boys. So I designed and built and created these inserts that make the leg more sturdy. And I glued it in just with super glue, which works really well. And so now I have a card that has secure legs and stands very secure when you move it around, and most likely, unless you're really aggressive with it, shouldn't break. Now, let's get to another aspect. I put this back in, and again, I've written, let me point this out, on the back of this card, I've written the word top, and this, I consider this the top, these are the legs on the bottom, and it has to be oriented this way for a very specific reason. So the first thing you need to do is you need to label. Let me find the labels here. Where are they? Here they are. The labels are here. There's, I don't know if you can see this, I have an A, and an A is your first measurement when you go to calibrate using this tool. And with the calibration set to A, you need to create a little nib that goes in the back here. And that nib is just hot glue. I used a hot glue gun to make a little nib. And this might need to be moved forward or back, but I basically tried to align it in the center of this flat portion with this V as close as I could to the video. And I don't really have that distance there. It's not highly critical because it can move forward a little bit or back, and then you can just make adjustments later. But I used a hot glue gun, so that will fit in the hole in the middle of the turntable. So that's A. And so you put it in A, you put it in the turntable like this, and it spins around and calibrates, and no problem. Now it asks you to flip it over, and opposite A is down here upside down, I've created B, side B. And side B goes this way, and there's a nib off to the side here. Whoops, side B has a nib off to the side. And that nib is right in line with this line right here. Goes all the way down and it comes up to there. So you count 1, 2 squares over, and it's right in line with where these two meet up, right there. And I used a straight edge to get that nib, again with hot glue, placing this the best I can because I've never seen the nib before, right there. And so you put that in the turntable, and then that will allow you to calibrate side B. And after you've done side B, it will then ask you to remove the card, which you do. You put that aside, and then you put your calibration tool in the middle of the turntable and recalibrate it doing side C. So this is basically side C, and I have a little C right here on the right side of the form facing up. So I know that that's side C, and side C is pretty obvious. And so there's no nibs. You just put it on the turntable. You hit the button, and it calibrates using this, and it'll say calibration finish, and you'll think you're done and everything looks great. But the image will be a little distorted in certain areas. And that's where you need to align the lasers. And that's what we need to discuss next. I should also mention here, I did not measure from the wall to the black square, or from the top to the bottom here, or from here to here, this blank white area. The calibration card I believe you get with the Makerbot scanner is a slightly larger, but I had to retrofit it to the frame that was available that was on Thingiverse. So I believe that this distance might be a little off. And this distance here, all the parameters around the grid pattern, I believe those margins are slightly off. And maybe that's why my card does not calibrate 100% accurate. Now, I did make sure that these grids are up and down vertical in relation to the table or to the flat surface here. So what I did was I took a speed square, you can use anything, and you just want to make sure that when it lines up, that it lines up perfectly square that way. And you also want to make sure that the edge here is square that way. And that's the best I can do, getting that vertical and horizontal to this card. And I did that for the side A and B, and then for the interior in here, side C. And that's the best I'm going to get making this myself without having any card to reference. You can call Makerbot and they'll give you these numbers and you can try to make it more accurate. I wasn't able to do that, so I didn't go into detail on how to align that. The critical part for me was the square, making sure all the squares were accurate. I used a CAD program to print these out, very accurate, and then also the number of squares and the orientation of the grid pattern and that sort of thing. So I hope I've showed the card that I've made here to the best of my ability. That's what I have. I figure the white area above doesn't get scanned anyway. I don't think it really plays a significant part. I think what's critical is the layout and orientation of the black and white checkerboard. That's what I kind of focused on. It may be that this needs to be a little bit higher, or maybe this card needs to be a little bit lower down. I don't know. I don't have the card, so, or the tool, the calibration tool, so I can't measure it against anything. All I can do is figure, well, whoever made this frame was probably pretty accurate, I hope, about making the frame. And so I can't see the calibration card being bigger left or right or top and bottom of the frame. So I kind of just measured it to match the calibration tool that was scanned. And so that's why I came up with this size. One of the steps, step C, to align your laser, or not step C, I'm sorry, the third step in the software asks you to align the lasers by putting the tool like this and measuring the red and red lasers along this axis here. Well, instead of doing that, I suggest using a straight edge, putting this on top of the turntable and then measuring the lasers along this edge, this real fine edge here of the speed square. So, and I'll show you more of that when I go to align the lasers using the scanner. So this is the calibration tool. I think I've gone over the whole thing, so I hope that helps. So these are the two additional braces that I printed, and I'm going to glue in with super glue. Basically, there's a little lip right here on this side and this side, and there's a left side, and it just keys in just like that. And what that will do is once that's glued into place, it will offer more strength for these little legs, because this leg is really flimsy, and if you drop this, you could wind up snapping this leg, and then you got to reprint this whole thing again. And so I devised these little kind of inserts that have a little flange. Like I said, I don't know if you can see that little, there's a little flange right there, and it will glue nice and tight just like that. And what it will do is once it's glued in, it will offer additional leg support and make it one cohesive piece and make it much more stable and easy to move around and use, and hopefully not break. So let's talk about the hardware you get with your scanner, your Makerbot Digitizer 3D scanner. It's just a couple components. First and foremost, hopefully you get the calibration tool. If not, you got to make your own. Second, there's a power wall wart, we call it. It's like a little power converter that you plug a PC cable, cable into, and then you plug this cable into the back of the scanner, and this is the power supply. This is the PC cable that you also need to plug into the power supply. It plugs in straightforward like this. There you go, like that. And the last thing you need is a standard USB cable. Mine came pre-cut, so I had to fix it, but you can buy this anywhere, get a new one if you need to. But it's just a standard USB and then another USB standard plug there. I don't know the type of plug that is. It's kind of a D-shaped plug, a square boxy one, but that's what you need, and they're readily available. Now, the other piece of hardware you get is the scanner itself, and mine came cracked. I knew that. The guy told me that ahead of time, so that was fine. It's just superficial. It's just cosmetic, so it doesn't affect the scannability. The blue tape here, please ignore that. I'll explain later. But this is a turntable that spins very, very slow. It takes about 9 minutes to do a scan, and there's a minute or two of processing the mesh, and then you got your scanned object. And you can do multiple scans. I've actually been told that, or read online, that between 1 to 3 scans, multiple scans are best. I do 1 scan and I get a good image, but if you want to do a cup and you want to do the inside of the cup, you might need to do 2 or 3. Don't do 4 or 5 or 6. What happens is the mesh gets worse and worse, and you lose a lot of detail, and you inject a bunch of bits that make it not come out very well. So I don't recommend doing that many. Stick to 1 to 3 at most. Next, I want to explain, this is a laser and this is a laser, so it has a left and right laser. This is a red filter that moves out of the way, so here's your camera. And with the camera, you will have just a normal looking color picture, but as soon as you slide this over, everything turns red. And what that does is it allows the camera to only see the red lasers as they project on your object that you're scanning. That way you don't get a couch or a desk or a chair or something in the background. So that's fundamentally the layout of the scanner. You'll see a little knurled screw hole here in the base of your turntable. I called Makerbot, and they didn't really know what it was, but they presumed that it was for it was going to be used for a future release of this digitizer. It was going to have a post that could screw in there and maybe hold objects. They didn't really know, and I thought initially it might have been used to lock the turntable during shipment, but I don't think it is. In addition, no one could seem to figure out what these little slots are for, and I believe the slots were going to be key holes for having a screen over here, so that when the lasers aim at your object, it's blocked, and I'll tell you why that's important here shortly. Lastly, on the bottom of your laser, there's supposed to be rubber feet, which I am missing, but you can buy rubber feet and install them anytime you want. On the back of the scanner, this is where the USB cable plugs in. This is where your power cable plugs in. This is the on-off switch. This is where next the number 15 Torx screwdriver comes in. I don't know if you can see that, but it's like star-shaped. There's screws. There's a screw hole here and here, and same on the other side. I don't know if you can see that very well, but there's one here and one over here. That's a little bit out of frame. The outer screw, Torx screw hole, allows you to adjust the laser, how vertical it is. It moves the top and bottom like this. And the inner Torx screw moves the laser left and right. So it's critical to set this outer screw perfectly vertical first before you start adjusting the left-right movement on both sides, on the left side of the scanner and on the right side laser. And that's something you're going to need to do for sure. And that's there's some software that helps you adjust these lasers as far as where they align on the table side of the bed, of the turntable. Basically, what you're supposed to do is you align the laser. You put your card, not your card, but your tool, your calibration tool, with the A side nib down into the hole, and you need to align it along this edge. Well, since I didn't make this or design this calibration tool, I'm not sure this is perfectly vertical. In fact, I didn't even, you can check it with something like this, and it seems to be pretty vertical. I mean, it just appears. And I guess you could use that. It seems close enough. But when you go to calibrate your lasers, I suggest using a straight edge like this that is much more accurate. Basically, you want to, when you calibrate the laser, as far as whether it's vertical this way or this way, you want to align it on this edge, and to do that, you're going to have to use the software and I'll show that later in the video. You have to go in and turn the lasers on and then hand mechanically adjust them until they're right. They actually say that the lasers should crisscross in the middle center hole here, right in the center. And that's how I start the calibration. I first turn the laser scanner around and have it face the wall. That's critical. You also want to have it some black background on the wall so you don't get reflection from the wall back into the camera. That's also critical. I then use a much larger speed square to set the vertical height along the black background, and I'll show you that later also. So I actually have two sizes of speed squares. I have a shorter one and a larger one, and I use them both. Now, you can use whatever you want. You can pick these up relatively cheap. They're made of plastic. You can buy them. Home Depot probably has the two sizes for maybe $5 or $10. You may want to invest in that. You don't need metal ones. Plastic ones will work just fine. You just want something that has a very good accuracy of verticalness to the spinning table. That's important. So I'll move these out of the way. And so, given all that, that's basically what we need to do to start calibrating the lasers, and I'll show you how this works adjusting these screws on both sides, here and over here, for adjusting the verticalness, making sure the laser is perfectly vertical, and then moving the laser left and right so that the two lasers crisscross in the center of the turntable. So I want to list and show you the primary tools I used to make the calibration card and to calibrate the lasers on the 3D scanner. First and foremost, you're going to need some white filament. I used Hatchbox, but you can use whatever you want, to print out the frame on your 3D printer. So obviously you have to have a 3D printer. I use that to print the actual frame of the calibration tool. And from there, once I had the calibration tool printed at a good enough quality, I then bought some foam core, some white foam core. That's what this is. And I cut out my AB card insert in the calibration tool. And to cut that out accurately, I used these speed squares, a small speed square and a larger speed square, because you want really straight lines and really right angles. And in order to cut the foam core back here, you need one of these. You need like a knife that is sharp, and can cut through the foam core with the first cut. So I recommend getting one of these little, I call it a mat knife. I'm not really sure what the hell it's called, but just a inexpensive X-Acto knife. And it has, like I said, it has a really nice long blade, so you can really get a good cut the first time, because coming back and cutting foam core a second time does not work. Second, or third, you're going to need some double-sided tape to tape the grid pattern to the foam core back here. You're going to need a glue gun, and I bought Gorilla glue sticks for their extra durability and adhesion to the calibration tool frame. You can use whatever you want, but these are what I use to make the little nib. And I used the super glue to glue in the extra little supports for the leg, because if the leg breaks, you got to start all over. And I want the legs to support the card, even though I bang it around. I don't want it to break, or else you got to make the whole card again, and I don't want to do that. You do need a very small or a smaller metric ruler that can measure the little black squares and white squares and the offset of the frame to where the checkerboard pattern should be centered in the middle of the calibration tool. That's important. I have a larger ruler here that I use to lay out and cut the foam core back here. And that's primarily all I use. The only other additional last tool you'll need is a number 15 Torx screwdriver for adjusting the lasers left and right and vertical settings on the back of the Makerbot 3D digitizer scanner. And I'll show you how this tool becomes important a little later on. So I wanted to include in this video a number of the pictures that I have associated with this scanner. Some of the pictures I got from Makerbot that show close-up images of their scanner card, and I want to include that in the video, so you can pause the video and then look at the calibration and how to generate each of the black and white grids. So I'm including it here in the video for your convenience, but I also have the files available for download. So I just wanted to start off here. This was the box that I received from Canada that I ordered the scanner from. It wasn't in great shape whatsoever, slightly crushed, but the scanner still works great, and it just goes to show how durable these scanners are. The calibration, of course, was completely messed up and had to be redone, but short of that, it still worked great. I just kind of wanted to show, don't give up hope. These scanners do work, regardless of the how they're shipped. So I thought that was kind of funny. So let's look at some of these scanner cards, and I'm going to pause and not say anything to give you time to go ahead and pause the video and really look at and blow up these images. So I'm going to go ahead and not talk, but maybe what I should do is maybe tell what each picture is roughly and then let you look at it. So this is the insert card with the 1.2 millimeter square checkerboard pattern. Down at the bottom down here is the little nib that you need to anchor for part B of the calibration. This is the part C of the calibration, the inside of the calibration tool. And you can see down here, theirs is actually broken. But all in all, it's pretty close to what we have, what I have generated. I think the gap here is different than the gap up here, but I don't know if it really makes any difference because this is all white space. The gaps on the left and right are the same. These are lined up, and you have 3 here and 3 here, black squares. So I don't know. I tried to copy it the best I could, so I'll leave it here for a little bit so you can look at it. This is a calibration card I just found online. Somebody found this card at school and doesn't even know what it's for. They have no idea what this thing could be worth to someone. So I tried to find it. This was sent out years ago, so it's long gone. Okay, so lastly, here we are with the Thingiverse calibration tool downloaded and printed. I printed using Hatchbox filament, which worked quite well. And this is what I was talking about. These legs are really thin, and if you drop this card on the ground, you could snap off this leg, and then now the whole card is no good. It'd be very hard to keep it perfectly level, I think. It's kind of top heavy. And here I have the nib, hot glue gun nib showing right here. What I actually created were these 2 left and right inserts that glue in here and glue in here using super glue that stiffen up and secure these legs in a good position, in the correct position, so that if you do drop it or knock it over, you don't snap off the legs and have to remake the whole thing again. And I have these STL files available for download. So I think that's about it. I hope that you enjoy my videos and download my videos and share my videos. And more importantly, I hope you subscribe to my videos so that I can make more of these to help everyone with their projects now and in the future. Thanks.